Geometry, Chapter 10, Lesson 5, and we want to look at using trigonometry to determine area. And what we're going to be looking at specifically is continuing our study of the area of regular polygons. So we're going to use the same formula, A equals 1/2 AP, but when we draw our apothem and then we draw our triangle on the inside, what we're going to discover is that with certain polygons we don't get to the nice 30, 60, 90 or the 45, 45, 90 triangles in order to figure out the apothem or the half length of that side. So we're going to have to use another tool in our toolbox, trigonometry, or sine or cosine, or most often tangent, in order to determine the apothem lengths. So let's take a look at this quickly. You remember from what we've worked with already that the area of any regular polygon can be determined by using 1/2 AP. The apothem is the segment that's drawn perpendicular to a side, so we're looking for the perpendicular side when we look at a diagram to identify the apothem. And then we had these two radii that we draw that create this triangle, and we do 360 divided by the number of sides to find the measure of this angle here, and then when we draw the apothem it cuts that angle in half. And so far, every time we've had to do that, this angle up here ended up being a 30, a 60, or a 45. But in certain regular polygons, that's not going to be the case. So here we have, we're asked to find the area of a regular pentagon, and because it's regular, we want to do 1/2 AP. And when we draw our two radii and divide by 360, we get an angle of 32. And when we draw the apothem, it cuts that angle in half, so that gives me a 36-degree angle here. Well, the 36-degree angle obviously is not a 30, it's not a 60, and it's not a 45. So in order to figure out the A, which is my apothem, I'm going to have to use trigonometry. And again, what we have to do is go back and look at what we did before. Here's an angle that's 36. The 4, which is half the side because the apothem cut that side in half, is opposite of this 36-degree angle. And the apothem, which I want to know, is adjacent. So which ratio uses opposite and adjacent? Well, that would be the tangent. So we're going to be able to use the tangent to figure out our apothem. Okay, so let me kind of walk down here. So the tangent of 36 is equal to 4 over A. That's opposite over adjacent. And when we solve that, we get an A value of 4 over the tangent of 36. Now here's where we do not want to make a calculation. We're going to use this as the apothem. Remember that this fraction here and all that's inside of it actually represents just one number. Whatever number you would get when you calculate it, that's what this represents. And those numbers are equal, so we can just use this, because this is an exact representation, moving forward in our formula. So if we substitute in the formula, we have 1/2, and then we have our A, our apothem, which is 4 over tangent 36, times the perimeter. One side is 8, 5 sides would be 40. And so I have 1/2 times this apothem number, whatever it is, times 40. And now I can go ahead and do my arithmetic. So I can take half of the 40, which would be 20, and then I have a fraction times a fraction, so 20 times 4 would be 80, divided by tangent of 36. Or I could take half of the 4 and get 2 over tangent 36, then multiply that by 40. Either way, I end up with an exact answer of 80 divided by tangent of 36. So this is the area of this figure, and this is my exact answer. Now, if I wanted to calculate the answer, I would then go ahead and put that in my calculator as 80 divided by tangent 36, and I would get about 110 centimeters squared as my answer. So again, there's nothing different in this lesson. There's nothing different. We haven't changed anything. All of the things that we're using are things that we've used before. Tangent ratios or trigonometry, the 360 divided by the number of sides, calculating the apothem. All of that material is still the same. We're just using the trigonometric ratios because of what we end up with in our triangle. The Castle del Monte, built on a hill in southern Italy around 1240, makes extraordinary use of regular octagons. One regular octagon from the inner courtyard has a radius of 16, so what would be the area? So basically what we have is an octagon, and we're given this radius of 16. Well, the radius is not the apothem, so I'm going to have to calculate that. And the radius also is not part of the side of the regular polygon, so I'm going to have to use it to calculate half of the side and then double it and then give me the perimeter. So as we do our 360 divided by 8, I get 45, and drawing the apothem cuts that 45 in half, so this angle in this little triangle is a 22 and a half. So I'm going to have to use trigonometry in order to calculate my apothem and my perimeter. Now I'm going to have to use the number 16, so I can either calculate the half side, the perimeter, doing opposite over hypotenuse, which would be sine, to calculate x. And for the A, I'm going to do adjacent over hypotenuse, which is cosine, so both of those will be involved as we move forward. So if we determine the value of A, which is the apothem first, the cosine will be the adjacent side, which is A, over the radius, or excuse me, the hypotenuse, which is 16. So this gives me my equation. So as I solve this for A is equal to 16 cosine 22.5. Now that is my apothem. And again, I don't want to calculate anything here. That represents my apothem, so we're going to leave it exact. Then to help me find the perimeter, I can do opposite over the hypotenuse. That will give me half of one side. Well, if we think about how many sides we have 8, and if all of those sides were divided in half, that would be 16, right? So I'm going to have 16 of these values that are 16 sine 22.5. So from here to here is 16 22.5. That's half of one side. So if I double that, that will give me one side, and then if I multiply that 8, that will give me all of these sides. Or I can determine, well, if this is a half, in 8 sides there's going to be 16 halves, so that's going to give me a total of 256 times the sine of 22.5. That is my perimeter. Okay, and what they did here is 8 times the length of a side would give me the perimeter. The length of one side is going to be 2 x's. I determined that x was 16 times sine 22.5, so substituting that in, I get 256 sine 22.5. Now that is my perimeter, and again, that's my exact, so I'm going to leave it. So now I can substitute both of those ratios that I've solved for into my equation. So I get the A is 16 cosine 22.5, which I have here. My perimeter is 256 sine 22.5. So I can either take half of the 16 and have 8 cosine 22.5, or I can do half the 256, get 128, and then multiply that by the 16, or then multiply those two values together. Either way, you can calculate those however you'd like. But again, we want to leave these ratios alone until we get to the end. And then I could go ahead and calculate that, so I get a courtyard area of about 724 square meters. Okay, so again, nothing really new there. We're just going to use trigonometry to figure out our apothem. We're going to use trigonometry to determine our perimeter, substitute those values into our formula, and calculate the area.